Good morning. Welcome to lesson 7.5, exponential functions. Today we're going to learn how to graph an exponential function. An exponential function is an equation that is in the form of y equals a to the x power. Y equals a to the x power, where a cannot equal 0 and b cannot equal 1. Okay? The equation that they give us here is y equals a times b to the x. So we're going to take it nice and easy. I'm going to explain two things to you really quickly. So first thing is this. If the equation is in the form of y equals a to the x, and a is a number greater than 1, 2, 3, 4, or anything to the x power, the graph is going to look like this. It's going to open. It's going to go from the left to the right, and it's going to make what we call half of a U-shaped curve. Half of a U-shaped curve. Are you guys with me? So this is probably something important. I would put this in your notes. If y equals a to the x and a is greater than 1, so a is a number greater than 1, that's what your graph is going to look like. Now, underneath it, if a happens to be a fraction, any fraction, 1/10, 1/16, 1/4, 1/3, 1/2, then the graph is going to open the other way, the opposite direction. This graph right here actually never ever touches the x-axis. However, it becomes extremely close. So when we graph these, we're going to actually make a table. We're going to pick points. We're usually going to use 0, 1, 2, -1, -2, okay? And we are also going to state what the y-intercept is. Remember, the y-intercept is where the graph crosses the y-axis. You all with me? Yes? All right. Does everybody have that in their notes? Okay, I'll give you a minute to get that in there. All right, so let's go ahead and do our first example together. Our first example here is y equals 3 to the x power. So what I've gone ahead and done is I've already know in my mind what my graph is going to look like. So my graph is going to look like this. How did I already know that? Because I know that if a, this number right here where the 3 is greater than 1, that my graph is going to have that shape. So now I make my table and I plug in my points, 0, 1, 2, -1, -2. And you could either use your calculator or you could use your brain, whichever works best for you. 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9. 3 to the negative first power is 1/3, and 3 to the negative second power is 1/9. So if you were to look at it, you could realize that 3 to the first power and 3 to the negative first power are inverses of each other. That will help you. And now here are your ordered pairs. 0, 1, 1, 3, 2, 9, -1, 1/3, -2, 1/9. And so now this must be done on graph paper, so now I'm ready to go ahead and to graph these points. Label your x and your y. So my first point is 0, 1. My next point is 1, 3. My next point is 2, 9. Then I have -1, 1/3, and so I'm going to basically estimate that. And then I have -2, 1/9. So my graph's going to look something like that. So if I were to say to you, thank you so much, what is the y-intercept? You should all be able to tell me what it is, because the y-intercept is where that graph is crossing the y-axis. The y-intercept is what, guys? 1. Now, somebody might be thinking in their mind, does the y-intercept always equal 1? The y-intercept will always equal 1 when your equation is in the form of y equals 3 to the x, 4 to the x, 5 to the x. But if we have something like 3 to the x, and then we have a number over here, plus 1, plus 2, plus 3, or minus, then it will not be equal to 1. Does anybody have a question on this example, y equals 3 to the x power? Okay, let's look at one where, sometimes they're going to ask you for the domain values. The domain values are what could all the x's equal? They could equal all real numbers because they could equal positive numbers, negative numbers, and 0. What would your range values be? Your range values would be numbers greater than 0. Positive numbers greater than 0. Okay? Let's do one where we have a fraction. Y equals 1/3 to the x power. Y equals 1/3 to the x power. All right, so again, I've picked my points. The one that I've given you in your notes is y equals 1/4 to the x. So now we're going to give you an opportunity to do one that's a little bit different. So I picked my points, 0, 1, 2, -1, -2. We know that 1/3 to the 0 power is what? 1/3 to the first power is 1/3. 1/3 to the second power is 1. 1/3 to the negative first power is, and 1/3 to the negative second power is 9. Okay, so let's make sure we understand already in our mind. So let's go ahead and tell me what the graph should look like. So let's go back here for a minute. Should the graph look like A, or should the graph look like B? Very good, because when it's a fraction, it's going to look like that. Okay, so now we are ready to graph our points. The first point is 1/3, 0, 1. The next point is 1, 1/3, 2, 1/9, -1, 3, and -2, 9. Let's just pretend 9's up there, and it's going to look like this. And you just have to kind of fudge it a little bit to make sure it comes down close to the x-axis. So if I were to ask you what the y-intercept is on this one, what would you all tell me? The y-intercept is? Good job. Good job. All right. Let's do one where we have to, let's do y equals 3 to the x plus 1. Okay, y equals 3 to the x plus 1. So let's make our table. Our x values 0, 1, 2, -1, -2. Use order of operations, guys. Exponents first. Feel free to use a calculator. 3 to the 0 power is 1, so 1 plus 1 is what, guys? 3 to the first power is 3. 3 plus 1 is 3 to the second power is 9 plus 1 is 3 to the negative first power is 1 plus 1/3 is 1 and 1/3. 3 to the negative second power is 1/9. 1/9 plus 1 is 1 and 1/9. So in your mind, you need to decide, is the graph going to look this way or this way? I'll give you letters, A or B. A. This is a whole number. If this were a fraction, then it would be B. So the graph is going to look like that. So now we are ready to graph it. Zero, 2. So now you're going to see one where the y-intercept is not 1, but in this case the y-intercept is going to be what, guys? Good job. 1, 4, 2, 10, -1, 1/3, -2, oh, excuse me, 1 1/3, so that should be right there. And this one is going to be 1 1/9, a little bit lower. Should be flat here, sorry. Let me fix that. I don't like the way that looks. Let's fix that for you. You with me? Any questions? All right. Yes. The domain and range is always going to be the same. The domain and range is always going to be, well, in this case, the domain values are all real numbers, but the range values in this case are what? It's anything greater than what? No, not greater than 0, but in this case it's greater than 1. And I'm going to be honest with you, I don't even think that I test on that. So basically this is what I'm interested in. Make a table, graph it, and tell me the y-intercept. Are you with me? Okay. That's icing on the cake. Okay, the second part of our lesson here is determine whether the set of data below shows exponential behavior. Write yes or no and explain why or why not. Okay, so let's go ahead and give you this opportunity. There are two methods to determine if a graph shows exponential behavior. One way to tell is by graphing it and looking at the shape of the curve. Okay. The other way would be to actually remember that there is a pattern that has to take place. So the domain or your x values are going to increase or decrease by the same number, which means this, guys. You're going to either add or subtract the same number to all of the x's. Does that make sense? And then the y, or the range values, you are either going to multiply or divide by the same number. So it's not the same thing for both. The x's are being added or subtracted, the y's are being multiplied or divided. Okay? So the x's could be adding by 1, the y's could be multiplied or divided by 2 or by 3, or are you catching on? But there has to be a consistency. So let's go ahead and check our x's. 0, 2, 4, 6, 8, 10. So what are we doing to our x's there? Plus 2. Let's see what we're doing to our y's. 64, 32, 16, 8, 4, 2. Dividing by 2, or we could say multiplying by 1/2. So according to that, does this data show exponential behavior, yes or no? And so we would say yes. X's plus 2, y's times 1/2, or you could say divided by 2. Now, the other option, which I think takes a little bit longer, but if you're not sure and you can't tell a pattern, then you would go ahead and graph it. And so this is what the graph would look like. The graph shows rapidly decreasing values of y as x increase. This is characteristic of exponential behavior. Are you with me? So let's go ahead and let you guys try one. Let's try one. Let's do number 1. I'll let you guys do 1 and 2. Determine whether the set of data below shows exponential behavior. Write yes or no and explain. So I'm going to be really very clear on this. So in your homework tonight, when you see problems like this, how many answers are they going to have, guys? How many? I can't hear you. 2 answers. Good job. Make sure I get 2 answers, okay? 2 answers. A yes or a no and an explanation. When you're done, raise your hand so I know you've got it. All right, who's got the first one? Yes or no? Who wants it? Thank you. What did you get? You got no. Why? Okay, good job. So when you state the answer, you should say no, which is correct. Even though the x's are increasing by 1, the y's are being added by 1, so there is not a common ratio. Good. Number 2, what did you guys get for 2? Yes.
Yes.
Yes, why?
The x is adding 9 and the y is
Good job. Does anyone have a question? Are you sure? Okay, this concludes our lesson for today, and it will be uploaded, and you can watch this on YouTube.